SpaceX's Starship program is known for pushing boundaries, and its recovery efforts are no different. The company has always been at the forefront of innovation, constantly challenging the status quo and redefining what is possible in space exploration. While most eyes are on the latest prototypes soaring high above Texas, a different kind of recovery made headlines. This unexpected event captured the attention of space enthusiasts and experts alike. Ship 31, a veteran of a high-altitude flight test back in 2021, was unexpectedly retrieved from its watery grave in the Gulf of Mexico. This recovery operation was both surprising and intriguing, sparking curiosity about the reasons behind it. This retrieval, months after its intentional ditching, wasn't just about nostalgia, it was a treasure trove of data. The information gathered from this operation could provide invaluable insights into the performance and durability of the Starship design. Ship 31's journey began in December 2020, culminating in a successful high-altitude flight and a dramatic, fiery landing attempt. The mission was a significant milestone for SpaceX, showcasing their ability to push the boundaries of space travel. The prototype splashed down in the Gulf, seemingly lost to the ocean depths. Many believed it was gone for good, a relic of a past mission. However, SpaceX surprised everyone by recently recovering Ship 31, pulling it from the water after almost 3 years. This unexpected recovery operation demonstrated SpaceX's commitment to learning and innovation. The unexpected recovery offered a unique opportunity to study the effects of prolonged exposure to saltwater on Starship's materials and design. This kind of real-world data is crucial for improving future designs and ensuring the durability of spacecraft. This wasn't just about understanding how Starship handles a salty splashdown. It was about gathering comprehensive data that could influence future missions and designs. It was about gleaning insights that could inform the design of future Starships, particularly those intended for ocean landings. These insights could lead to significant advancements in the way SpaceX approaches spacecraft recovery and reuse. The recovery of Ship 31, despite not being part of the initial plan, proved invaluable for SpaceX's engineers. It provided them with a wealth of data that could not be obtained through simulations alone. It offered a real-world experiment, providing data that laboratory simulations simply couldn't replicate. This kind of hands-on experience is essential for pushing the boundaries of what is possible in space exploration and ensuring the success of future missions. Recovering a spacecraft after a test flight is no easy feat, especially when dealing with the massive components of Starship. The process is intricate and requires a well-coordinated effort from a highly skilled team. SpaceX employs a multi-pronged approach, focusing on retrieving the most valuable and reusable parts. This strategy not only saves costs, but also accelerates the development of future missions. One key target is the COPV tanks, responsible for housing helium used to maintain pressure in Starship's fuel tanks. These tanks are crucial for the spacecraft's operation, and their recovery is essential. These tanks, made of high-strength composites, are expensive and time-consuming to manufacture, making their recovery a priority. By reusing these components, SpaceX can significantly reduce the cost and time required for future missions. Another critical component is the heat shield tiles. These tiles are designed to withstand the extreme temperatures encountered during atmospheric re-entry. These tiles, designed to protect Starship from the scorching temperatures of atmospheric re-entry, are vital for the spacecraft's safe return. Without them, the spacecraft would not survive the intense heat. Recovering and analyzing used tiles provides crucial data on their performance, helping to refine their design for future missions. This data is invaluable for improving the safety and reliability of the spacecraft. SpaceX teams meticulously remove these tiles from recovered Starship sections. Each tile is carefully handled to ensure it can be reused or studied for further improvements. They study the wear and tear patterns, looking for ways to improve their resilience and effectiveness. This analysis helps in making the tiles more durable for future missions. The recovery process involves a combination of specialized ships, remotely operated vehicles, and skilled technicians. Each element plays a crucial role in ensuring the successful retrieval of spacecraft components. Divers and ROVs brave the ocean depths to secure the massive components, attaching them to cranes on recovery vessels. This underwater operation is both challenging and essential for the recovery process. Once back on land, teams carefully dismantle the recovered sections. This step is crucial for understanding the condition of each component and planning for their reuse or improvement. They meticulously catalog and analyze every part, searching for clues that can enhance future designs. This detailed examination helps SpaceX to continuously improve their spacecraft, making each mission safer and more efficient. While SpaceX has become adept at recovering and reusing Falcon 9 components, retrieving an entire Starship after a flight test is a significantly more complex endeavor. The Falcon 9's recovery process, though impressive, pales in comparison to the intricate procedures required for Starship. Starship's sheer size and the forces it experiences during re-entry pose considerable challenges. The spacecraft must endure extreme conditions that test its structural integrity and systems to their limits. Unlike Falcon 9, which lands vertically on a designated landing pad, Starship is designed to perform a belly flop maneuver during its descent, controlling its fall with aerodynamic surfaces. This unique approach allows for a more controlled descent but requires precise engineering and execution. This maneuver, while impressive, makes a controlled landing more difficult. The spacecraft must transition from a horizontal to a vertical position just before touchdown, a feat that demands exceptional precision. The intense heat and pressure exerted on the spacecraft during this phase make it susceptible to damage, potentially rendering a complete recovery impossible. The heat shield must perform flawlessly to protect the spacecraft from the harsh re-entry environment. Despite these challenges, SpaceX remains committed to making Starship fully reusable. The team is constantly innovating and testing new materials and techniques to enhance the spacecraft's durability and performance. The company continues to refine its landing techniques and improve the spacecraft's heat shield system to withstand the rigors of atmospheric re-entry. Each test flight provides valuable data that informs future designs and improvements. A fully reusable Starship is crucial for achieving SpaceX's ultimate goal of making space travel more affordable and accessible. This vision drives the relentless pursuit of innovation and excellence within the company. Each successful recovery and reuse represent a step closer to that goal, driving down the cost of space exploration and opening up new possibilities for humanity's future among the stars. The dream of interplanetary travel becomes more tangible with every milestone achieved.